Let's get started. Hi, my name is Jonas Sicking. I'm with Mozilla. I am the tech lead for the Web API team.
And hi, I'm Vivian Nicolas. I work for Mozilla and I'm the tech lead for Gaia, the front-end part of the Firefox OS project. Is it better? Yes, much more. So hi again, my name is Vivian Nicolas. I work for Mozilla as well, and I'm the tech lead for Gaia, the front-end side of the Boot to Gecko project.
So we're going to talk about Firefox OS today, or as we're going to eventually call it, GNU Linux Firefox OS. Yeah, so these, I hope you can sort of read that. Let me try to zoom in here. You had some last-minute slide issues. Firefox OS is a open source project. It uses Gaia, which is the front end, which is entirely written in web technologies using HTML, JavaScript, CSS, JPEGs, and so on. Behind that is Gecko, which is the rendering engine that we've been using for Firefox for over a decade. And then under that is a Linux kernel. We're using the same Linux kernel as Android is using. And the reason for that is because a lot of hardware manufacturers are already targeting Android or the Android kernel, which means that A, it's easier for us to find partners, but B, it also means that it's easier for anyone else to install Firefox OS on a device that already supports Android. So why are we doing this? Well, mostly because it's cool. Web technologies are awesome. We want to use the web in more places. But also because we really believe in open source, open standards, and creating a community-driven operating system. We don't want to have something where just the source code is available. We want a project where anyone can participate. The latest version of Firefox OS is available on GitHub and Mercurial. Anyone can pull and build whatever code we currently have. There's no surprises. All the planning happens in the open. Anyone can participate and submit patches just like anyone has been able to do for Firefox. So one important point is that it's not done yet. We have not shipped Firefox OS anywhere, but we are very close. We are going to ship in Q2. We have hardware and partners, hardware manufacturers and partners lined up. So we're going to have devices running Firefox OS selling in stores in Q2. It's not a worldwide release though, but hopefully we'll get to that point eventually.
Thanks, Jonas. So when we started the project 1 year ago, it was really, the front-end part was, oh, let's do this very nice operating system. We have an ID. And the first demo was done in August 2011, I think, and it was mostly just a version of Firefox Mobile with a UI dedicated as an home screen, and the phone calls were using the Android stack. All the UI, there was part of some Android UI. And it was looking really like shit. So we spent the last year changing this. We made a complete UI based on HTML, JavaScript, CSS. We reached some incredible performance. We use CSS animation transition. We reached 60 FPS on most of the transition. You may have heard about PDF.js. We can use it on desktop to read PDF. We can use it on the device. So with JavaScript, we can read PDF on such a device. So what is it? So I don't know if it's visible. So as most fun, you start with a load screen. Let's do some CSS. Transition animation. I don't know if the camera looks right to see the 60 FPS. So the fun, as most other, is composed of a system application. So you see the black bar at the top of the screen is the only visible part of the system that is here all the time. It uses already some APIs to show the status of the SIM card, to show the battery. So you can also, so the battery is the battery API. It works already in WebKit, so you can try it. There is a notification center. And all the other part is on screen. It's made of moving parts and always here part, a dock, which is always here, where you can add 8 icons. But you can also do, it's a phone, so let's prove it. Let's see if Jonas can call me like. Okay, or can send me a text message. Which number do you use?
Oh, this one? Demo number?
No, it's this one. Okay, yeah.
No. Which number should I say?
Okay. Oh, there is no SIM card on this one, sorry. Oh. So obviously it does not work without any SIM card. That's still a web-based phone, but to make phone calls we need one. So my SIM card is actually in the other device. So we can show it after that during the question phase. What else? So you can obviously send, receive SMS, access your contact. You can browse the web. We made a web browser in the browser. So you can, and I don't have any SIM card, so I don't have access to the network. Let's see if I can connect to the Wi-Fi. Let's connect to Wi-Fi. So we have a lot of APIs to enable access to hardware capabilities of the phone. Let's see if it's... So yes, we got it. Now let's go up. Nice. So it's looking for a network. You can see that on the top. It's coming. The Wi-Fi is a bit slow, so it's coming. So you can navigate the web. You can load because. And one tab is not enough, so let's open a new one. And hope it will load faster. So, yes, nice, the same. So each of those tabs lives inside their own process. So every time you create a new tab, you spawn a new process. And most of the phone architecture is based on this. We will speak a bit about it later. So one of the other things is normally you cannot do a browser using regular web APIs. So we have an extended version of the iframes that let us listen for some events on the page, title change, load change. So we can do more stuff. So we enhance the web stack to be able to do such apps. So it's not, one network is still coming. So let's kill some apps. You have all the basic functionality of different phone. You can browse your gallery, see your girlfriend, see the last guy I work with, or main contributor, the best cat. It's not very visible, so let's try. So you can edit picture on the fly. So we use WebGL and some shaders. So we have hardware accelerated 3D effect, well, 3D. You can listen music directly from your phone. If you don't have many music, you can listen talks from Mozilla. So here is Brendan speaking about Boot2Gecko 1 year ago. Yeah.
Yeah, let's.
Hey, Brendan, do you have anything to say? I don't know if you can hear him, but he's with us. He's very happy. So you can do much of the thing you can do with your regular phone. There is no, it works, you can use it as your daily phone, and if you have another proprietary phone, you don't need to use it, you can switch, and you don't care. So, obviously, you still need more stuff. You want more. So what can we do if you want to install more things into the device? Jonas, do you have any suggestion for us?
Yeah, so any modern smartphone has to have apps, right? Apps is cool. So we have we have enabled apps on Firefox OS. So we have a marketplace. Let's see if the web or if the internet connection here is good enough that this will actually load. This is the normal issue with demoing. It doesn't seem like we are actually getting any connectivity here. Yeah, so we have the ability so basically all of the applications or icon-looking things here are real apps. This is not just one giant web page that has built-in support for camera and for making phone calls and so on. Each of these icons is actually a app, which means that it's a small package of JavaScript, HTML, and CSS and so on. So let me bring up the right slide again here. So apps in Firefox OS are entirely done with web technologies. But the web as it exists today doesn't support apps, like we just have web pages. But what really is the difference between a web page and an app? Well, mostly, or at least to start with, it's an icon on the home screen, right? How do you get an icon? Well, we need a little bit of metadata for the app. So we've introduced a JSON manifest where you express what name the app should have, what icon, what URL to load, and so on when the app launches. We also have two types of apps. We have what's called hosted apps, which is essentially just a normal website with this little extra metadata sprinkled on top of it so that you can get a home screen icon. And then we have something called packaged apps. Packaged apps is sort of what it sounds like. It's a zip file that contains all of the resources. So when the user installs a packaged app, we download this zip file and store it on the device, and then anytime you use you launch the app, we load from the zip file. So here's what, oh man, this is not rendering at all. Sorry, this camera is not working out. So this is supposed to be an example of what a application manifest looks like. Yeah, I don't think that we can fix that. So basically it's just a little bit of metadata. It's the name, it's a list of icon sizes and which URL to use for these icons, and it's some information about the developer and so on. and additionally to this, we need a little bit of API. In particular, what's been very important for us for Firefox OS is that we don't want to have a solution like some other operating systems have, or mobile operating systems have, where there's only one store where you can get applications. What we want to keep the web open, so people shouldn't have to submit their apps to a particular store. So these APIs that we've added for managing apps actually allow any websites to become a store. And this is a very big deal because it means that anyone can set up, you just set up a normal website, and then you can start selling apps for Firefox OS and for other platforms that support the same type of web apps directly from your website. You don't need to have buy-in from the device manufacturer. You don't need to make your own device. You can simply put up your website and start selling apps. So this API both lets the store install applications. We have like an install function, a check if this app is installed function, and so on. It also manages updates, so we can keep apps up to date all the time, because it's very annoying when it's very important to have users be running the latest version of an app for security reasons. Another thing that we have enabled is, so for packaged apps, it's obvious that they will work if the user is not online. But we want to keep, packaged apps aren't very webby. We wanted to keep the nice things about the web, which is that you just put a bunch of files on your web server and then anyone can use it. So how do we make that work together with this expectation you have for something you've downloaded and installed, which is that it should work even if you don't connect to the internet? We've integrated with the app cache. This is a feature of HTML5, which allows a website to enumerate the set of URLs that should be cached. And then these are cached so that they're reliably available. So when you launch your app, we don't even have to hit the network. We can immediately load these cache resources from the device. So offline, even though this is based on the web, offline will work just fine. And the experience that the user has is no different just because it's web. It's no slower. There's not like this incremental rendering. Like you don't see the images like slowly load. Everything is instant. We're just loading resources locally, assuming the app is set up correctly. So in addition to having these APIs to manage applications, we also expect that applications can do more than the web can do. Right now on the web, you sort of everything is very safe because the web or web technologies don't have access to very many things, which means that it's safe to go to any website. Well, for apps or for an entirely web-based operating system, we have to extend those capabilities. So what we did was we added we tried to find a small set of capabilities that we had to add to the web, and then we wrote specifications for this that we have submitted to W3C, and we're now working with W3C to standardize for adding the set of things that you would want to be able to do. But we've always kept the sort of the mindset of the web, so everything is standardized, everything is JavaScript friendly. It basically feels like just like developing a web app, even though you're interacting with, for example, a telephone API. There should be some example code there, but it's sort of washed out in this camera. So we've added, so basically the device can do anything that normal apps, that you would expect of a normal mobile operating system, even though it's based on web technologies. So we also saw the gallery. The gallery uses another API that we added, which is device storage API. The device storage API the gallery is essentially just rendering images. We've always been able to render images on the web. The little piece we're missing is the ability to go to your images folder and enumerate all the images that are there. So we've added the device API, the device storage API, which lets you ask for the pictures folder or the music folder, and then you can enumerate all the files that are there and treat them just like any normal file. So like you can just point an image tag at one of these files, or you can point a audio tag if you want to play music, and so on. So there's only a very small set of capabilities we've had to add, and in general, the web has a tremendous set of functionality already. We've also added a browser API. You can sort of make out a little bit there, because, of course, we needed to have a web browser, right? So what we did was we extended the iframe element with a couple of things. We have the remote equals true attribute, which says run the contents of this iframe in a separate process. This is what allows us to do a multi-process browser application, even though it's entirely based on HTML and JavaScript. So you just set an attribute which causes Gecko to create a new process and then run the contents of that iframe in a separate process. We also added a Moz browser attribute, which makes this iframe element behave slightly differently. A page that's rendered inside of this iframe doesn't see that it's inside of an iframe. It just sees what a web page normally sees. It looks like it's the top-level browsing context. So we've had to add small changes to web technologies, but in general, we've kept with what's there and tried to reuse as much as possible. And then just add APIs that sort of look and feel like normal JavaScript and web APIs. So let's try a demo. One thing that we kind of looked at Android for some inspiration. Android has these intent system, which allows applications to talk to each other. In Firefox OS, we've actually sandboxed applications very, very strongly. There's no way for applications to interact with each other. We've done this for security reasons. So installing an app is very safe. Just because you have like a bank app doesn't mean that if you install some evil app, that the evil app can get to the contents of the bank app. But we still want to enable applications to talk to each other through dedicated channels. So let's see if I can get this demo running. So what we have is we have something called web activities. Web activities lets a website or an app say, I want to perform a particular action, and then Gecko will look through, or Firefox OS will look through all the applications you have installed and see which applications can handle this action. So if I launch the get image or pick activity, I get a list of all the apps that support this activity, and then I can choose the camera app here. And this will render, not so great. Well, this launched the camera app, but the camera app is not very happy if you don't have a memory card in. Sorry, we switched, last minute switch of device here. That's a bummer. Actually, I wonder if I can make it work. No. Okay, but web activities is basically a subset of intents and lets applications use the system to perform certain actions. And this allows, by installing additional applications, you can sort of expand the capabilities of your phone and the capabilities exposed to other web applications. This also allows any apps that you install to integrate with your phone. So this use the pick activity. So any app that you install, so for example, if you install a Flickr app, the Flickr app can then integrate and let you choose pictures from your Flickr account and so on. And again, this is just like a small addition we've done to the set of web APIs that already exist in order to integrate and allow this richer ecosystem of apps. So let me switch. I think that might be... Yes, that's all I had.
So if you also want to see it working, you can come at the booth. We have a lot of awesome people with demos that works, not like us. So feel free to come and to see the device. We have a few devices. So another important thing is once you have installed all those apps, the one you have by default, the one you are going to find on the marketplace. Jonas spoke about the browser API for the browser application. We use the same thing in the root, what we call the system application. So you can think of Gaia as a web page that contains iframes that just point to your apps. So those iframes use the extended version, use the iframe as apps. So what happened then is the system just show and hide iframes. All of those iframes are like web pages. They are contained into their own process, their own sandbox. They use IPC to communicate to the main process and to Gecko to say, oh, I have navigated to a different page. I want to use such thing. I want to show such thing. And closing an application is just removing it from the DOM. Another way to close application is those kind of font does not have a lot of RAM. So if the device runs low on memory, it will kill the app, and that will give more free RAM for the action you are currently doing. I think we have less than 10 minutes left, so let's answer some questions if you have. Do you have the phone number? Oh, yeah. And if you're too shy to ask questions, I think this phone is supposed to work, and hey, this is your number?
No.
Okay.
No, that's not the number. Don't show that.
Oh, fuck.
Let's keep it.
Okay. So is there any questions?
Yeah. I've got a question. I'm currently running Firefox OS on my Nexus S, and so far, great job. There are two things that I've noticed that are missing. One, bizarrely, the browser doesn't seem to have Firefox Sync, so I can't actually sync my bookmarks, history, etc., as I could on Android or other device. The other item is there's no CarDAV sync for contacts.
I can't really hear you. Yeah.
Sorry. Is that better? Okay. Yeah, running Firefox OS and Nexus S works great for the most part. Two omissions is no Firefox sync for the browser, so no bookmark sync, etc. And also...
No what boxing?
Sorry? Firefox sync for bookmarks and history, etc. Is that...
Yeah, so we don't... so first of all, this is the initial release that we're working on. We didn't add sync support yet because it felt like we had more important things to get working first. We're absolutely planning on adding sync support as soon as we can. There is one thing that makes sync a little bit tricky. As we've designed Firefox OS, we really have tried to make it so that the built-in applications aren't special in any way. So we don't want the Firefox browser, that's the built-in browser, to be more special in any way than if you install another browser. And so we need to figure out how to make syncing of bookmarks work with third-party browsers. Would be ideal, but yeah. So we're absolutely planning on adding sync. A, once we have sort of the basics done, and B, once we figure out a model where we can allow any app to integrate with sync.
And I take it the same goes for contact sync using CarDAV? You've got CalNav in there for the...
Contact sync is actually, we don't have it implemented, but it should be quite possible to build contact sync using a third-party app. We have a contacts API, which lets you, basically do anything with address book. You can enumerate anything that's in the address book and add and remove contacts as you want. So all you need to do is to write a third-party app which starts itself every regularly and then syncs with or downloads data from whichever source you want and inserts contacts into the contacts database. Okay. So the contacts API actually makes contact syncs quite possible to implement using third-party apps.
Lovely. Thanks.
Hello, I have a question concerning the security. One big problem on the Android platform is the huge number of malicious applications and still rising. Should we expect a similar problem on Firefox OS, or is there some security mechanism that will avoid it?
I couldn't.
On the Android platform, there is a huge number of malicious applications, malwares, yeah. And how Firefox OS is ready to fight this problem?
So the security model we have, we started by making things very, very strict. So the way that the security model works is every app is very tightly isolated from the system as well as from other apps, which means that even if you install an evil app, it can't really do anything. Like it can't get to any data unless the user explicitly lets the app do that. There's actually some trickiness to how the security model works. Some APIs that are extra sensitive. There's some APIs that are so sensitive, like telephony, which there's even like regulations and so on around. We don't expose to third-party apps for now until we get allowed to do that. Other APIs, we only expose once an application has been reviewed. So certain applications will have to go through Mozilla Store for now. Oh, yes, so that actually worked. But but in any case, even in scenarios where you've gone through and been reviewed, we always ensure that the user is informed anytime we share private data with an app. So you could write in theory an app that downloads your contact address book, but you can't do it without the user getting informed. Like, hey, this game that you just installed wants to get all your contacts, and then you can maybe think like, do I actually want this? What's also very nice in Firefox OS security model is that we don't ask these questions at the time of install. So with Android, you have to make these security decisions when you install an app, which is when you're the most eager to just go through and start playing your game or whatever you want to do. And you also don't have any context, like why does this app want to access my contacts? In Firefox OS, you don't make any security decisions when you install. Instead, the first time the application tries to use a sensitive API, at that point, we ask the user, and the user can say yes or no. You don't have to, like in Android, you can't run the app at all if you want to disallow some permission. In Firefox OS, you can just say no to this particular thing, and then everything else continues to work. Yeah.
Hi. One question. Are you going to support closed source applications, and how?
We have no plans to support anything but web technologies, which means like everything is going to be JavaScript and HTML and CSS. So you can sort of close source in the sense that you can use an obfuscator just like people do on websites today. But there's no way to run binary code. Like you can't like deliver a x86 binary blob and have it, or an ARM binary blob and have that run. It's all JavaScript. But we can't really prevent people from obfuscating their source, so people can and will do that.
Another question?
Hello, I have a question regarding the power management. How does Firefox OS how does Firefox OS compares to Android in terms of battery life? Did you do any tests regarding power management or power consumption? Yeah, battery life is the keyword.
I don't actually know. I think we do quite okay compared to Android. But I haven't personally done any measurements, so I don't actually know how we compare. But I mean, one of the things that is nice by the way that Firefox OS works is on Android, for example, you have like many different stacks. Like if you're running an app, you first have you have to run through the JVM. If you're interacting with web pages, you have to go through both the some Android stuff on top of the browser technologies and so on. So in some cases, we definitely have an advantage of having like just a single runtime, which is the web runtime. But I can't say if that translates into any significantly different battery life.
Okay, one last question.
Hi. First of all, I think it's awesome that you guys are trying to do this, and I think I really I want it to happen. You know, I mean, I think it's super important. And I think it's super hard, and it's awesome someone's trying. The question is, do you have any idea how much this phone will cost?
Can you hold up the microphone more?
So, do you have any idea how much this phone will cost? Do you have a target? The Firefox phones, the cost?
So the initial release is targeting very low-end devices. So this device that it's kind of hard to get a sense for the performance here because the frame rate of the camera we're using here is very low. But we have like for scrolling and so on, we have 60 frames per second, and that's on very, very low-end hardware. So I don't know what the actual price is going to be, but it's some of the cheaper smartphones that you can get on the market today. And so that's what we've been developing against, and so that's what we've optimized. So we do get quite good performance on very low-end hardware. Of course, we're hoping that at some point we will have people selling more high-end hardware running Firefox OS, but the initial release is for very low-end hardware. Okay, there was one very quick question that I should mention. We do support Do Not Track, because someone was asking that on the SMS there. I think we may have some form of third-party cookie blocking. I know that third-party cookie blocking in general tends to break the web. I don't think that we've solved that any better in Firefox OS than in Firefox. But it's there. I think you can turn it on. Okay, that's all. Thanks, everyone.
Thank you very much.